Welcome to today's lesson. Today we are continuing with a critical number. So by definition, a critical number of a function f is a number c in the domain of f, that is in the domain of the function, such that either the first derivative of the function at that point c or at that number c is 0, or the first derivative of the function at that c and that number does not exist. So let's take some typical example to see this. So let's find the critical number of these two functions. 1, my f of x, or the function, is 5x squared plus 4x. The secondly, my f of x, the function, is x to the power 3, is x to the power 3 plus 3x squared minus 24x. Okay, to find the critical number of this function, we first set the first derivative of the function to 0. Doing that, for my first function, I'm having 5x squared. Let's do that well. Now, we first find the derivative of this function. So my f prime of x is going to be my 10x plus 4. We then set this to 0, where my f prime of x is 0. To find that particular number of function, that particular number in the domain C that is equal to 0, that is going to be my 10x plus 4 is 0. I can see that divided by 2, where my 5x plus 2 is 0. You can see that that is going to be 5x is minus 2. But finally, my x is going to be minus 2 on 5. Okay, so this is a critical number. And we realize that we need to check the domain of this function. Since this function is a polynomial function, the value minus 2 on 5 is defined within this domain. We need to realize that for a polynomial function, it is defined everywhere. Therefore, this my minus 2 on 5 is within the domain of the function. Now, we can as well find what the critical point of this. Finding the critical point, we then insert this value that we have gotten here into the function to get a corresponding value, the y corresponding value of this. What this means is that we are going to find f of minus 2 on 5 to see what that is. Finding this, we are going to see 5 minus 2 on 5, this is squared, plus 4 minus 2 on 5. Okay, so breaking this further, f, let's take that away. So this is going to be my 5 into bracket 4 on 25. 4 on 25. This is plus minus, let's put that into bracket. This is minus 8 on 5. Alright. Then let's see what this is going to give us. This is going to be equal to this 5 cancel here. This is also 5. So we are going to get what? 4 on 5 minus 8 on 5. And this is the same as minus 4 on 5. So it means that for this point, the critical point here is minus 2 on 5. This is minus 2 on 5, comma, minus 4 on 5. Alright. So let's proceed to the second one. To find the critical number of this, we also as well find the first derivative of this function. Finding the first derivative of this function, we are going to get, first, our function is x3 minus 24x. Alright. So the f prime of x of this function is 3x squared minus 6x minus 24. So here is plus, so we'll do that plus, plus, and this is plus minus 24, right? So my f prime of x being equal to 0, this implies that I'm going to get what? Equate this to 0. But then I'm going to see 3x squared plus 6x minus 24 equals 0. Alright. So here I can divide through by 3. I can divide through that by 3. And that is going to give me, let's first divide this. Alright. After I divide through this by 3, I know that what I'm going to get is what? X squared plus 2x minus 8. X squared plus 2x minus 8. And this is equal to 0. So when we now put that to find the corresponding values of x, we are going to get, so this is 1, 2, minus 8. So we are going to see that this is going to be x. We're going to get x minus 2 to bracket x plus 4 is equal to 0. Then we can realize that my x is equal to 2 or my x is equal to minus 4. Alright. So these are the critical numbers, and we also have to identify that this certainly falls within the domain of the function. Since this function is a polynomial function, all the values of the critical numbers that we have gotten falls within the domain. We then proceed to find a critical number. Finding this critical number, we then find a function at 2 and as well the function at minus 4. So let's first proceed to find the function at 2. But then first, what is our function? X cubed plus 3x squared. So let's put that here. F of x is what? X cubed plus 3x squared. Now this is x cubed plus 6x minus 24. Right, fair enough. So that is going to be 2 to the power 3 plus 62 minus 24. So this is x, right? Yeah, so let's check our function here. Well, yeah, exactly. So this is x, so x is here. So this is 2. So let's see. So that is going to give 8 plus 12 minus 48, which is the same as what? R minus 28. So one of the critical points is what? 2 minus 28. Secondly, we find the critical point for this one as well. So f at minus 4, this is going to be minus 4 to the power 3 plus 6 minus 4 minus 24 minus 4. All right. So this is going to be, we then put this here. This is the power 1. Okay. So this is minus 64 minus 24. This is 24. So this is going to be plus 24 times 4. This is 96. So we see what that gives us. 24 plus 96. This is positive 8. So our second critical point over here as well is going to be minus 4, 8. Alright. Let's now see how we can use this critical point to find out maximum, global maximum, and global minimum. How this aid us to find that. Okay, so finding the absolute minimum and maximum in a closed interval. To find the absolute maximum and minimum, values of a continuous function on a closed interval, that is a, b. For example, we first do what? Find the values of the f at the critical numbers of f in that interval. Then secondly, find the values of the function f at the endpoints of the interval. So what this is first saying is that let's first take a typical example, and then with this example we then proceed. It says that we first find what the values of the function at that critical point in the interval by giving the function to be my f of x. Let my f of x be x to the power 3 minus 3x squared. Let's do that one. Minus 3x squared plus 1. Alright. So this is my function. So find the values of f for the function at the critical numbers. So as we did earlier, we need to find the values of the numbers or the critical numbers. That we first find what? The first derivative of the function, where we set it to 0, where this is going to be 3x squared minus 6x. Alright. We then set this to 0. We are having what? F prime of the function to be 0. And this is 3x squared minus 6x to be 0. We can still divide this through by 3, where we are going to get x squared minus 2x to be 0. Alright. So with this, what we can then do is that we can set, okay, let's see, this is 3x squared minus this, right? This is equal to 0. Okay. With this, we can do what? Factor out x. Factoring out x, I can see that x is equal to, factor out x, I can get what? My x minus 2. This is equal to 0. I see that my x is equal to 0, or my x, okay, so let's put that here, or my x is equal to positive 2. So I then get two values for my critical number. Okay. Then it continues to say that find the values of the function at the endpoint of the interval. But then we need to be given an interval for this. So let's consider an interval for this to be, considering the interval, maybe minus half, this is less than equal to x, also less than equal to positive 4. Okay, which is actually the closed interval. Let's put that well. Which is actually the closed interval. So finding the function of the value, finding what? The function at this endpoint of the interval. First, what that means is that we are going to get the function at what? Minus half, and see what that gives us. But before that, we can also first put what? Find the critical point. Finding first the critical point, we can realize that we need to first find the function at 0. Finding that, so let's do that. The function at 0, because this is one of the critical points. Finding the function at 0, I'm going to get this is 0 to the power 3 minus 3 0 squared plus 1, which is the same as 1. So one of my critical points is, so let's take this outside for now. One of my critical points is, let's put that here, is 0 1, comma. Then secondly, my another critical number that I had is for 2, so I find my f of 2. This is the same as 2 to the power 3. This is 2, sorry. This is 2 power 2 plus 1. And this is going to be equal to, this is what? This is 8 minus, this is what? 3, 4 plus 1. And this is what? This is 8. This is minus 12 plus 1, which is 8 minus 12 plus 1. This to this is 9 minus 12. which is minus 3. So we can put that here, take these guys away. So this is minus 3. Alright, so we have now gotten what? Our second critical point, which is this is 2 minus 3. So this is our second critical point. Then we proceed to find the values of the function at the endpoint of the interval. Since we have this closed interval, we then find the function at this point. So f at what? Minus half. This is going to be minus half to the power 3 minus 3 into bracket minus half to plus 1. All right. And when we do that, you are going to get 1 on 8. This is kind of 8. The same way, we have f, the function at what? Minus function at 4, which is the end, one of the limits, the closed interval, the end. We are going to get what? This is 4 to the power 3 minus 3. This is 4 plus 1. Doing that, we're going to get 17. All right. So we're also going to realize that this is going to be a different point, another point, which is going to be minus 2, 1 on 8, which is minus 2, this is minus half, comma, 1 on 8. And then here as well, we are going to get what? 4, 17. So we have gotten what? 4 points for this function, okay, for this graph. We have gotten 4 points. Now, to determine the absolute maximum and minimum, you realize that the function at 4 gives us what? The highest number for this function. So the function at 4 among all these points gives us the highest, which is what? 17. So you realize that at this point, the function will be at what? The global maximum, which is 417. And then the function to be at what? A global minimum. You realize that within this 4 points as well, when we put what? At the critical point 2, you realize they gave us what? Minus 3, which is actually what? The global minimum. Sketching that, let's do some rough sketch here. See, so then see that we have this, and then we have this. All right. So with that, you can say, okay, let this be a 1, this be a 2, this be a 3, this be a 4, minus 1, minus 2, minus 3, and all that. 1, 2, 3, 4, minus 1, minus 2, and all that. So let's first see our point. We first had one of the points to be 0, 1. That 0, 1 is 0, 1. So we can see that here, black. We can see that here with 0, 1. And then we also have 2 minus 3, 2 minus 3. This is somewhere here, 2 minus 3. So we are getting that to be here. And then minus half is going to be somewhere here. Minus half, 1 on 18, which is just somewhere here. Okay. And then lastly, 4, 17. This is going to be 4, 17. 4, 17. This is going to be far high, 4, 17. So we can trace that to be, we have this. Well, we are going to have this. Before we are going to have this. And it proceeds on. So we can see that at the highest peak over here, which is actually 4, 17, is going to be our global maximum, but our global minimum is going to be the point here, which is our 2 minus 3. All right. Thank you.